Hello, my name is AmirAli, and in this presentation, I'll be discussing the 3 points. Point 1, the changes of construction condition. Point 2, the changes in mechanical properties. Point 3, the changes in environmental factors. As the temperature rises, the workability of the concrete mixture decreases. The cause of this behavior are the acceleration of the cement setting process, as well as the faster evaporation of the mixing water at higher temperature. A rise in temperature reduces the compressive strength of concrete in comparison. Cracking can also occur as a result of water loss and shrinkage. According to AS 13791, the concrete consistency grade used in this situation is a plastic consistency grade, which requires a slump of 60 to 130 mm, with 80 mm being ideal. If additional water is added to the concrete mix at higher temperature to maintain or restore workability, the water cement consistency will increase, resulting in a loss of potential strength and durability. Limiting the cement content would be a more logical situation, as cement hydration causes a temperature increase. Changing the consistency, on the other hand, might have a significant impact on the concrete. Water reducers can therefore be used to lower the amount of water in the product or increase its usability. This enables for faster concrete application and compaction, which enhances the overall strength and durability, and most importantly, it does not result in a huge change in the original ratio. Metal A had an ultimate tensile strength of 2993.68 and a youngest modulus of roughly 210 GPa in assessment task 3. These findings indicated it as the metal with greater strength than metal B. The elongation percentage of 35.61% and the reduction area of 55% also highlighted how ductile this metal is. However, in order to change its mechanical properties and increase its yield strength and ultimate tensile strength, the metal must go through a few processes. Steel strength can be increased in a variety of methods, including increasing its carbon content. Another method is to heat treat the metal, which breaks the outer crystal and causes a chemical reaction that increases its hardness. The combination of these two processes is known as carburizing, and is a thermochemical process that infuses carbon into the surface of the metal. A brittle metal is not beneficial for this specific building element. However, this process allows for tougher outer layer but a yet softer core, allowing the metal to retain its ductility qualities while increasing strength. In the presence of charcoal and carbon monoxide, the metal is constantly heated and cooled by the addition of carbon, which results in an increase of hardness. Steel cables are utilized in the bridge to lower the structure's self-weight and are one of the elements used in assessment task 1. This bridge is vulnerable to corrosion due to Sydney's humid and coastal weather condition. This environmental factor is quite frequent, nevertheless it is more common in Australia. Zone 2C2 is the classification for this environment. Therefore, a hot dip galvanizing is the most cost-efficient method for preventing corrosion in these steel cables. According to the Galvanizing Association of Australia, steel structures on the road with the above environmental classification require a minimum of 85 micrometer of coating, the majority of which is zinc coating. Because of the semi-harsh environmental circumstances, this adds on an extra layer of protection. To summarize, it was obvious in discussion 1 that adding water can negatively impact the water to cement consistency and its ratio. Therefore, adding water reducing agents allows the workability to be maintained at a standard due to this high temperature. The second discussion focused on the technology that combines adding carbon and heat treatment to steel to increase its strength while keeping the ductility at the core, as it was required for that specific element. Discussion 3 examined environmental condition classification in order to take action in protecting steel cables at C2 environment, providing their structure and extended lifespan. Thank you.